equal to the work done. The actual formula is work done by time from the knowledge of your class 11. Now, work done is what? Work done is in the form of different kinds of energies according to the work kinetic energy theorem, work potential energy theorem. So work done is equal to energies. So when the work done is equal to different kinds of energies, one of the energies is heat energy. That's why whenever you have the concept of heat, you involve this power is equal to heat by time. Okay. So heat dissipated per unit time is what we call as power, or you can say heat is power into time. Now class, power's formula is as lesser. You are more asked to write the formula of heat. But anyways, both are the same. It's derived from the same formula. Whether heat is asked or power is asked, you use both of them. So heat is equal to power into time. Power is equal to I square R, which is V square by R, which is equal to VI. Okay. So H is equal to I square RT means why? Because the heat is power into time. Power is current square into the resistance. Or you can say V square by R or V into I. That's the actual formula of the power. SI unit will be joules per second, means 1 joule by 1 second. That will give you watt as the unit. Because power's unit is the same whether you use watt or you use joules per second. But joules per second is actually not the unit of power. When question comes, you have to use watt for it. Okay, don't use joules per second. That is not an actual standard international unit. Okay, when a unit is prescribed, you have to use that. When nothing is mentioned, we use the units like see, for current it is mentioned. We never use coulomb per second. Do you ever anytime use it? No, we use ampere. Anyways, current is a fundamental quantity, so in current we don't have any second question also. So that is what the power is. This much is needed in the bulb and all. Now see, an electric bulb has voltage and power rating as 100 volt and 200 watt respectively. So calculate the resistance of the bulb. See, voltage is given to you, power is given to you. Use the formula. See, when power and resistance and voltage are given, use the second one because the first and the third involve the current. Okay. So P is equal to V square by R. R is equal to V square by P. 100 into 100 by 200. That is simply, and this will be 50. 50 ohm will be the answer. Okay. Next is power dissipated. It is connected to a source of 50. Means instead of this voltage as 100, you use the new voltage that is given as 50. So it will be 50 into 50 by 50. You cancel it. Basically, in this question, you don't have any information about the current. So you are going to rely on the formula V square by R. And this is what this topic is all about. Means if you have voltage and current given, use VI. Avoid these two. If you have current and resistance given, only use this. Avoid these two. Because two of them will involve the third one. Fine. So take the screenshot of this part and we'll discuss, just write down the question in the notes. Then we'll come to the Kirchhoff's law and all. Yes, see, Kirchhoff's law basically has two laws. First law is the junction law. Junction law means whatever current, total sum of all the currents will be zero. Means whatever currents are entering the junction will be exactly equal to all the current that are leaving the junction. Okay. So I1 is coming, let's say I2 is coming, I3 is exiting, I4 is exiting. So sum of all these currents will be equal to zero. So towards the junction, let's say one current is positive. So I1 plus I2 will be equal to I3 plus I4, or you can say I1 plus I2 minus I3 minus I4 is equal to 0. Or you can shift the negative terms on the opposite side. Okay, that is the first law. That is KCL, Kirchhoff's current law. Second is the voltage law. That means the net voltage is 0. Sum of all the net voltage is 0. Now, this law is more application based. How? What you do whenever you have any cell present, the cell is present. See, one will be our direction which we'll choose. Clockwise, we'll form loops, and in those loops, we'll form directions. Clockwise, anti-clockwise, or anything, those directions we'll form. Now, the way in which our direction is chosen, the way which we have our direction, this is positive or negative taken. Means if we move from the negative to the positive cell, if we move means the direction that we have chosen in our loop. So if we move from negative to positive, the potential is plus E. If we move from positive to negative, we take it as negative. Okay, plus for negative to plus means lower voltage to higher voltage, small to big, so it will be positive. Bigger to small, it will be negative. Now, which direction is this? This is the direction in which we are moving. Cells do not move. We have chosen a direction where we'll be moving across the loop. That's the first point. Second is, apart from the cells, resistors will also be there in the circuits. Now, how are you going to manage the resistors? See, we have to write net voltage is 0 according to Kirchhoff's second law, which is the loop law, that the net voltage is 0. That's what we have to write. If the net voltage is 0 and resistor is present, so what you do? You calculate I into R, that will be the voltage. Now the problem is whether the voltage will be positive or negative. Whether the voltage will be positive or negative. So how to determine that? That is determined using the direction that we are moving and the current. The current's direction is fixed. You will fix the direction of current. You will apply KCL first and you will fix the direction of current. Then you will start moving. If you are moving along the direction of the current, means you are moving like the direction of the current. Okay, along, then you have to write a negative sign. I'll erase these white, but these are from your class notes only, from the batches in which you people are currently. So that's why these markings and all are done. And that's why the notes are complete also, because these are from the batch. Anyways, so like this, see, if you are moving along the direction of current is going towards the left, your direction of that loop particular is matching with the left. This will be minus IR. And if it is opposite, current is going downwards, you are going upwards, it will be positive. That's how you have to determine that. Okay. Then the next part is, or let's see this questions. Or do one thing. First write it, then let me discuss this. Just write down the scripts also. Okay. All of you are done, I think. No, only Safrina, Halima, and Anisa done.
Yes, ma'am.
Ma'am, the last point.
I'll just make you practice a question based on this.
Done, ma'am.
Okay, see, these are already solved questions. I take some other. See, if is a resistor here. Here we have a resistor. A, B, C, D. Let's say this is 2 ohm, this is 3 ohm, this is 4 ohm, this is 2 ohm, this is 3 ohm. These are the resistors present. You have to find the current in each loop using Kirchhoff's law. Now pay attention because this is the only question we'll be doing from here, and then we'll move on to series parallel combination. Okay. Now look, what you do, you have to apply KVL first, voltage law first. Sorry, CL first, current law first. What you do, you distribute the current. I forgot to draw the battery here. So here we have a battery of 4 volt. 4-volt battery is present here. Without the battery, there wouldn't have been any current in the circuit. Just resistors connected within the wire. Now let's say this battery, see, always start from the battery because battery is the part that will be discharging the current. So let's say some amount of current comes out. Let's say I current comes out. Now if I current comes out, let's say in this branch some I1 goes. So how much will be left for this branch? I is coming, I1 went. How much will go here in terms of these?
Ma'am,
Yeah. Yes, Alina. Say
which one, ma'am? From D to A?
D to A, yes.
Ma'am, I1.
I1 is going across dB. So I1 can't be there.
I minus I1.
What?
I minus I1.
Yes. I minus I1. Plus if 10 amperes of current is coming and 2 amperes goes off in one wire, how much will be left and will go in the other wire? What will you say? 10 minus 2? You will directly say 8. That means this is 10 minus 2 is 8. So that's same thing. I amount of current is coming. I1 has gone in this branch. So how much is left here? I minus I1 from here. Now bending of wire doesn't affect. So this will be I minus I1. Okay. Now I minus I1 is coming. I1 is coming. So here I1, if you add both of these currents, I1 will be cancelled and I amount of current will go. So see, we started with I, and in the same wire, we are receiving I. It means we have distributed the current well. If I was getting something else, I1 plus I2, one more current, see, we could have taken this as I2 also. But why do you want to increase the number of your variables, right? Try to keep your variables as least as possible. See, you can take this as I1 goes here, I2 goes here. But then there will be three variables, right? There will be three variables, I1, I2, and this I. So now I just have two variables, I and I1. Yeah,
In my school, they take it as I1 and I2, and at the meeting point of the junction, they will take it as I1 plus I2.
same thing. Same thing. That's what I'm saying. See, you are allowed to use it in any manner. This is what I did. How do you know you have to take I1 only in this branch? This becomes a very complex task then. It means Kirchhoff's law is impossible to determine. You have to see the psychology of the examiner, what is expected out of the question. No, nothing. See, you're free to choose. I have taken this. Okay. Let's say in this circuit, let's say Halima, you have taken in this, you wanted to take I1 in this, and you wanted, or you, let's say you wanted to take I, and in this wire you wanted to take I2, and in the first one you wanted to take I1. So this one, when I1 will come from here, and from here I2 will come, this will become I1 plus I2, right? So here I is actually equal to I1 plus I2. So what will happen? Let's say you have done this. In this branch, you have I1 plus I2. I2 has gone here, I1 has gone here. Fine. Now see, let's say I have used this, the one which I have taught you. When I have solved my question, I have solved this question. This branch where I1 is present, I am getting it as 2 ampere, and let's say my answer is correct. This is 2 ampere, just in case. Okay. So Halima, what did you take? You took this as I2, the same wire, the same branch. You took it as I2 because you have the free will. You don't know whether to take I1 or I2 or anything specific. So your I2 should be equal to 2 ampere. Got it? Your branches current should match. Your variables can be any. You take it as alpha, beta, gamma, zeta, anything. You take I1 plus I2. Now see, let's say when I solved this I, when I solved the question, my I came out to be 10 ampere. So Halima, in the question which you did by your method or by any method anybody did, your I1 plus I2 should be equal to 10 ampere. Means whatever we have assumed, the variables do not affect because our ultimate answer will be exactly the same. You can take I1 plus I2, you can take I, you can take I minus I1, whatever it is, your current should be just suitable because this is unpredictable. If I just have a single battery here, what if I take one more battery here? That will also be discharging current. Now, how do you know which battery will discharge I, which one will discharge I2? So this is nothing. What you have to do, you have to ensure that the same branches are receiving the same current. If there has to be 10 amperes across this wire, then 10 amperes should be there with whether it's I1 plus I2, I2, I1, I or any variable that you have chosen. Got it? Is my point clear to all, not just Halima, everybody?
Yes, ma'am.
Halima?
Yes, ma'am.
Okay. And everybody, please have a free will to use the Kirchhoff's law. I'll just tell you, advantage of Kirchhoff's law, biggest advantage of Kirchhoff's law is that you can write anything. for the equations. You just have to write it correctly. That's the thing. Like if I was getting something else, now I got I, and in my same wire, same amount of current is flowing. So that gave me an idea. Apart from that, you can write down anything that you want in the sense for the current. Okay, whichever way you want, you can write the variable. And second advantage of this is that you are confused about the series and parallel connection. You don't know whether it's in series, whether it's in parallel, or sometimes there are circuits which are neither in series nor in parallel. So what you do, you apply Kirchhoff's law, whether it's a basic simple question or a tough question. Kirchhoff's law will 100% give you the answer. You don't have to remember the formula for that. These advantages are there, but the disadvantage is actually heavier than the advantages. It's a very lengthy method. I will suggest you, if you have a question based on Kirchhoff's law in the option with some other question, skip it. इसमें बहुत ज्यादा टाइम लगेगा. पहले लूप फॉर्मेशंस होगी, फिर करंट की डिवीजन होगी, and after the division of current, if see it can happen, this is a very simple circuit that I just have taken right now. Even if there is one more resistor connect beside it, that makes one more loop here. We'll have more variables. There will be lots of confusions. It can happen you have mistaken something, so your current is not matching. In the same wire, here you are getting I2, here you are getting I1. You have to rearrange. So उसमें बहुत सारा time जाएगा just to arrange up the currents. And not only there, after applying KVL, you have to form the equations. Equations जब solve हो जाएगी, then you'll have to solve those equations. Now here only two variables are there, so two equations are needed, so two loops will be formed. Fine. When you have just three variables, just three, solving three equations during the middle of your board exam, it's a very tedious process. Don't get involved in there if you have option. If you aren't left with option, then there is no option. That's a different thing, right? But if you have the choice, skip Kirchhoff's law. Though it's, unless it's a thing that you know perfectly, like this kind of if these kind of questions are there, two loops, two currents, these will be solved quickly. But questions have come. I'll show you a question which we did in the class. See, this is a question from your NCRT. It's easy, it's fine, but it's lengthy. It takes a lot of time to discuss it also. That's why I didn't take up this question for this backup class. And see, after writing these equations, you have to solve them also. Many students are not able to do such questions. And I'll tell you one thing, in the board exams, it usually comes in option. That's why I'm saying this, okay? So I have told you the advantages and disadvantages. Whatever is suitable to you, you use it. If it's not there in the option, at least write it till the equations. At least only the final marks will be cut for not writing the final answer. So write the equations and all, this much you should know. That the examiner knows that you know how to apply KCL and KVL. This has come a lot in the exam, to write about what's the law, Kirchhoff's current law, Kirchhoff's voltage law, whether it follows conservation of energy, conservation of charge. These kinds of questions have come in your short markers. From this much has come. Am I clear to all?
Yes.
Okay. See, so we are going to take two loops over here. Loops means closed surfaces. First loop is A to B to D to A. Remember one more thing. Some of the examiners in CBSE, they cut the marks in the Kirchhoff's law for not writing the initial letter back. Because it's like it's A to B, B to D. A, B, D if I write, so it's like it's open. The circuit would seem as if it is open and not a closed loop. So in order to signify and yes, confirm it that yes, this is a closed loop that we are taking, the initial letter is rewritten. So loop is A, B, D. Now choose one direction where you will follow. Let me take any direction you can take. Like, let me take clockwise in this. Any direction you can take. And the directions do not have to have any uniformity. You can take anything. Now let me start from A to B. Now a resistor is there. What did I discuss with you? Whenever you have resistors, you have to use IR. Current is I minus I1. The resistance is 2. IR. Now, how are we moving? We are moving from A to B. How is the current moving from A to B? Means you are moving along the current. Along the current you have written in your notes. It's negative. So minus 2 I1 minus I2. I minus I1. Got it? Clear? Now, From B to D, let's move. B to D, you just have a register. Register, as soon as the registers come, apply Ohm's law. Current into resistance, 4 into I1, because in this wire branch only I1 is there. Current is going from D to B uphill. You are moving from B to D downhill. Opposite direction, positive. Now last is D to A. You are also going up. Current is also up. So positive or negative?
Negative.
Negative. Very good, Safina. So this will be minus 3I minus I1. Now this was KCL, Kirchhoff's current law. What are these? Voltage, 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 and sum of all the voltages is 0. Clear? Is this equation clear? Because solving part you all will be able to do at least where two equations are formed. If you see two equations are formed, then don't leave the question where you can attempt it, because solving two equations are very easy. Solving just two equations, but if you have three equations, it's actually lengthy. In physics, papers are unpredictable. In the boards, the papers sometimes are very lengthy. Last year paper was also lengthy. Let's take some opposite direction for this loop. What is this loop? This is B, C, D, D. Let's go anti-clockwise. So B to D. Now look, this is the same thing. We are moving downhill. Current is moving up. So it will be minus 4I1. Sorry, plus 4I1. We are moving downwards. Current is going upwards. Plus 4I1. Now D to C. Now comes the battery. Battery, we had a different rule. If you move from positive terminal to negative terminal, do we write positive or negative? Check.
Negative.
Negative. Very good. So minus 4. You don't have to multiply to anything. This is voltage already. These weren't the voltages. So we have to multiply and check. This is already the voltage. So 4 minus 4. Comes the resistor. This is 2 into I. Now, we are moving from D to C. Current is moving from C to D. Opposite is positive. Last, we are moving from C to B. And current is moving from B to C. So plus 3I is equal to 0. This is the second equation. This is your first equation. Solve them, get the values of I1 and I2. I and I1, like this. So you'll know what are the currents in each branch. Am I clear?
Yes, ma'am.
Write this and then series in parallel. Let's discuss it. Oh, very good, Alifa. You've calculated also. How much it is coming? I1 is coming 4 by 13. Okay. I1 is 4 by 13. So I guess you people can calculate. Now, okay, now let's move further. Till here, I have all of you written. Anisa, have you written? These two have written.
Yes, ma'am.
Oh, okay. Series and parallel combination. If I talk, you already know this. Series combination. Here in series combination, the current remains the same. The way the charge remains the same in the previous part, here the current remains the same. So different kinds of resistors are present. A single current I flows through the circuit, means through each of the resistors. So this says current, if the current is same, means voltages are different across each. When we talk here, voltages are different across each. Here it will be V1, here it will be V2, V3, like this voltages will vary. Now why the voltage is varying? Because resistor, I told you, devices, they change the current, they change the voltage. So, and the current is also due to branching. So see, total voltage will be given by V2 plus V3 plus V4 up till Vn. Now V is equal to I into R. Now V is I into R equivalent. V1 is equal to I into R1 plus V2 is equal to I into R2 plus V3 is equal to I into R3 up till N. Okay. So current will be cancelled. So R equivalent is equal to R1 plus R2 plus R3 up till R4. Means you just have to add all the resistors that are present. Okay. Now current through each resistor will be voltage. Voltage is the same in all. Voltage divided by the individual resistances. And if you want current through the entire circuit, take R equivalent. R equivalent will give you I equivalent. R1 will give you only I1. R2 will give you only I2 like this. Then voltage across each resistor. Voltage, you use the Ohm's law. V1 is equal to IR1, V2 is equal to IR2, like this, IR3, IR4, IR5, like this. Then last is power dissipated in across each resistor. So P is equal to I square R. Again, if you want to get power, total power of the circuit, use R equivalent. If you want to calculate the individual power, use IR1, IR2, like this. Okay. Look at this question. 5 ohm, 10 ohm, they are connected in series. If we talk about the R equivalent, they are connected in series. So R equivalent will simply be R1 plus R2. That is equal to 5 plus 10, which is 15 ohm. Okay. Total voltage. Total voltage which is present in the circuit. This total voltage is the one which is given. That is 10 volt, the connected one. Then we have total current in the circuit. See, when I require total current means I'll have to consider total resistance. So I will be equal to voltage total by R equivalent. The total voltage, total resistance, that they will only know give me the net value of the total current in the circuit. So this will be equal to 10 by 50, right? That is
Okay.
2 by 3. Okay, so let's leave it in terms of 2 by 3. Fourth is current across each. How to calculate that, class? Yeah. How to calculate current across each? Tell me. Will the current be even different? Why do you need to calculate? 2 by 3 is the total current. Individually also this will be 2 by 3. So I1 is equal to I2. That is 2 by 3 ampere. Okay. Final, it is voltage across each. This will be different. Voltages will be different. So V1 will be equal to C. IR we use IR. Yes. For V2 use IR2. Let's see, are we getting the correct answer or not? This is 2 by 3. R1 is 5. That is 10 by 3. This is 2 by 3 into 10. That is 20 by 3. Let's check, is it right or wrong? If I add both of it, 10 by 3 plus 20 by 3 will give me 30 by 3, that is 10 volts. I'm right? 10 volt was the one,
Yes, ma'am.
total voltage. Parallel, let's discuss, but series का देखो series का ना screenshot ले लो, and for the question just note down the question, though it's a very simple easy formula based question, but take the screenshot of this. Let me check my video.
Done, ma'am.
T class in parallel circuits, we have the voltage C, the current divides. I1 is I1, I2, I3, I. If I take out the total current, I equivalent will be I1 plus I2 plus I3 plus I4, the net current will be. Now we know V is equal to IR. So I is equal to V by R. So current will be equal to V by R. I'll write that only. I equivalent, this is voltage equivalent by the resistance equivalent by V1, or in fact, we know we have to equate it. I'll just take it as V only so that we can cancel it right here. So this will be V by R1 plus V by R2 plus V by R3 up till. So voltages will be cancelled from everywhere. So what we will be left with? 1 by R equivalent is 1 by R1. Yes, reciprocal addition. Okay, you just have to add them reciprocally and this will be moving forward. Like this, individual currents, when you have to calculate voltage by resistances, you can calculate the net total current. If you want to calculate, use R equivalent. Let's see, rest of the things are the same. Okay, use the formula for voltage. First, R equivalent.
Ma'am, we did the previous question. We had to
Yeah,
find the total current.
yes. So we
No,
took total voltage and total resistance.
no, ma'am. The current, total current and the individual current is same. Is it same in all the cases? Like every cases?
Every case of series. This is a series connection, only in series. Okay, like this is parallel. So here current will be different, but voltage will be the same. When we have to calculate R equivalent, it will be 1 by R1 plus 1 by R2. And if two resistors are given, you can use this also directly. R1 into R2 by R1 plus R2. So this is 5 into 10 divided by 5 plus 10, which is 50 by 15. So that is 10 by 3 ohm. R equivalent is 10 by 3. Now look, here we have the total voltage. Total voltage is given in the question. So total voltage is still 10 volt. Third part says total current. So total voltage is there, total resistance is there, total current can be calculated. Total current in the circuit will be equal to total voltage by R equivalent. This is 10 by 3. 10 will be cancelled. 3 goes up, that is 3 ampere. Then it says voltage in each. Now see Halima, in this case, the voltages will be the same. V1 is equal to V2, which is equal to the total voltage. So in this case, the voltages are same because it's a parallel connection. Finally, current in each. This time current will be different. See, if I want to find I1, I'll use V1 by R1. If I want to find out I2, I'll use V2 by R2. I1 will be V is 10, R1 is 5. So that becomes 2 ampere. I2 will be, this is 10 by 10, which is 1 ampere. See, 2 ampere, 1 ampere. If I'll add it, I'll get the 3 ampere back. Means the calculations are correct and justified. So this way you can just check it. Okay, different kinds of circuits are there. These kinds of circuits, how to solve. Whenever equivalent is connected, no, equivalent term is present. What you do, you connect a battery between them. Like if I have to calculate what is the E equivalent value for here, A and B. So what you do for such questions, you put the battery wherever the question is asking. If you have to calculate equivalent voltage between A and B points, just put a battery there. So that will give you an idea from where you have to start. See, then you will start from here, these two in series, the resultant, these two in parallel, the resultant in series with this. Then they resultant in parallel with this, then all the three in series. Getting my point? Are you getting this question? Or should I explain in detail? Just tell me that that's only how will go, how I will go.
Understood.
Understood? Okay.
Yes.
There's one more case of infinite. Huh. See, for infinite series, what you do, class? Infinite series, you identify the repeating terms. Okay, I'll just tell you the method, calculations and all, you can do it later. Like in this, I can see 1 ohm resistor, 2 ohm resistor, 1 ohm resistor, 2 ohm resistor, 1 ohm, 2 ohm, like this. So identify the repeating term. Assume whatever answer to this, see, this is infinite, means infinite number of times 1 ohm and 2 ohm are connected. Are you getting? So this is infinite times. You can never calculate it through a simple method. You can't use a simple method to calculate, okay, I'll solve it using series and parallel method. It's not possible. It's infinite. Till where will you go and till where will you stop? So you identify the repeating term and you assume that total answer of this question is something. Let's say R. Whatever is this infinite, double infinite, triple infinite, anything, the answer is R. If the circuit is so huge that it is extending up to infinity, so with that, let's say I have solved this entire circuit and I'm just getting one simple resistor R. The R is the answer to this entire question. Now, if R is the equivalent resistance for such a greater number of resistors, what if I just connect just one more repeating term to it? This is R. I'm just connecting just one more repeating term to it. This is 1, this is 2. The equivalent now shouldn't be disturbed because what will these 1 ohm and 2 ohm resistor will do in front of a series which has infinite resistors connected to it? So how do we solve infinite? You assume total resistances are and just connect the repeating term with it. Now you see whatever will be the answer to this new circuit, the new resistance will still be equal to R equivalent. That is R only. So you can frame the equation. See, 2 ohm and R, they are connected in parallel. That makes it 2R by 2 plus R. And this 2R by 2 plus R will be connected in series with this. Because if you remove this, then 2 will be in series. So you can say 2R by 2 plus R plus 1. This plus 1 finally is still equal to R. Means just adding one small repeating term doesn't affect your final answer which you assumed initially. If I assume my answer is, let's say for instance is 1000 ohm. The answer to this infinite resistance term is 1000 ohm. Where I have connected infinite resistors, if I just add one more resistors, that wouldn't hamper any of the questions. On putting these 1 and 2 ohm, just one single, only one. I think even if you put 50 of them, that won't affect the answer. But just one circuit. So what will happen? If you put even just one circuit, there's still
How is it 2R by 2 plus R?
2R by 2 plus R in this way. 1 by 2 plus 1 by R will be equal to 1 by R equivalent. Take the LCM, R plus 2 by 2 into R is equal to 1 by R equivalent. So R equivalent will be 2R by 2 plus R. Got it? Parallel connection. Yes, Halima. Halima, have you understood?
Mm.
How these two resistors are connected in parallel, right? 2 ohm and this resistor, these two are connected in parallel. So parallel, what do we have? Look, these two are connected in parallel. These two. Do you agree with
Yes.
this? Now see,
Yeah.
how do we calculate? 1 by 2 plus 1 by R is equal to whatever is the R equivalent. Take the LCM, you get r plus 2 by 2r is 1 by r equivalent. What is r equivalent? 2r by 2 plus r. So 2r by 2 plus r. The resultant is 2r by 2 plus r. Means I can say the circuit now looks like this. 1 ohm with 2r by 2 plus r. Now is it clear?
Yes, ma'am.
Okay, now they are in series, so we have added them. These two have been added. But the final answer will still be equal to R only. Whatever we assume for the infinite circuit. Let's say my infinite resistors are making up the answer as 3 ohm. Infinite are there because they'll be subtracted also, divided also. Let's say it is 3 ohm. Just putting one circuit, one more resistor or one more repeating term won't affect my answer. It will still be equal to 3 ohm only, not even without approximating. So you equate this from here. This is just one linear equation with one variable. You have to solve and find the value of r. Because r is the one which we assume to be the answer. So if you get the value of r, you will have the final answer. Clear? Is this question now clear?
Yes, ma'am, it's clear.
That completes the current electricity part 2. Just take the screenshots of few things and
Ma'am, can you scroll up on down now?
which
To the
part?
question of the question two, ma'am.
Okay.
Okay, ma'am. Now you can scroll.
Ma'am, can you scroll a bit up?
Up or down? Where?
Ma'am, dance.
Okay.